We have a very interesting gentleman here. His name is Arun Majumdar, one person who possibly needs no introduction in Bay Area, possibly across the world as well, for a simple reason that he's somebody who created the first school, or who's the founding dean for the first school that was created at Stanford in 75 years. For the Doerr School, he's the dean here. In fact, one of the foremost authorities on climate and energy. Arun, I think you don't really need much more introduction from my side, but one of the most prolific academics that you will ever meet in your life. Arun, over to you for your talk, please. Thank you. Thanks a lot for joining us today.
Thank you. I want to thank Amit and Richard Dasher for putting this together. For those of you who are not from Stanford, welcome to Stanford. The last time I visited India was in August of 23 for the B20 meeting. This is Chandra, who's the chairman of Tata and also chairman of the B20, happens to be on my advisory board. So he said, why don't you come and join? Which I did. I don't know how Chandra framed it. I mean, the timing was impeccable because India had just landed Chandrayaan-3 on the south pole of the moon, which is an amazing historic moment. And if you combine this with the digital infrastructure for payments, the inclusive growth that the Prime Minister talked about, this is a very different India that I saw than even like 10 years ago. And I just left with a sense of pride. There's a contagious optimism. And there's also recognition that I think India is on an inflection point in its trajectory, which is amazing. I also reminded, when I was on stage at the B20, I reminded people that this is not an accident. When you land on the moon, from the US experience, I can tell you, this is not an accident. This is the tip of the iceberg, and this is the product of an innovation ecosystem that then you recognize the landing on the moon, but there's much more behind. So just to give you an example of what happened in the US experience. When people landed on Apollo 11, 1969, with a call to action in 1962, which I'm going to go back to. At that time, what is now recognized is that whole innovation ecosystem, in addition to the moon landing, produced integrated circuits, cellular communication, lasers, fiber optic communication, the internet, early days on the internet, 1968, was the first communication between computers. Some of you out here, UCLA, Santa Barbara, were involved, and many, many more. So one can ask the question, okay, so India is poised for innovation. What should it focus on? Well, certainly it has done an amazing thing in the digital side. I'd like to offer a perspective which I think is potentially the greatest challenge of this century, and along with the challenge is an opportunity. And is the opportunity to seize, and it's up for grabs for anyone. And the question is, will US and India seize it together? So I'm going to explain to you, in my perspective, of the global challenge, because this is a global issue, and India and US are global players. Okay, so let me fast forward. Okay, so this is the world population. And whenever I've presented this, MR reminds me, you scare the heck out of people. So I'm going to scare you a little bit. But I'm also going to give you the flip side of it, the opportunity. This is the human population. It took 1 million years for the human population to grow to 300 million. And now it takes 13 years to add 1 billion people, okay? This is not exponential, this is super exponential. I call this the human tsunami. Yeah? Along with the human tsunami, there's a human consumption tsunami. This is in terms of GDP. I put it in GDP because people are consuming, that's why people are producing, right? And this is a great story for human beings, because without this, we won't have the lifestyle that we have today. We would be an agrarian society of 150 years ago, right? This is a great story. Your life expectancy has gone up, our health has gone up, all of these things. We have information on our fingertips. That's all this. But it's a consumption tsunami. But to produce that, we have the energy consumption tsunami. And I put this only in the last few, those arrows are my family's generations. I was born in the 1960s in Kolkata, grew up in Delhi. My kids were born here in the 1990s. My parents were born in the 1920s and 30s. They went through this partition, if you recall, some of you. And my grandparents were born at the turn of the century, right? In fourth generation, we went from most of the energy from biomass to where we are today, 80% by fossil fuel. So it should not be a surprise to anyone that there is a CO2 tsunami, okay? And you can extrapolate this to the water tsunami. There's a biodiversity challenge, all of these things. So you are at a university. You'll get a quiz, and your lunch depends on it. No, I'm just kidding. I'm going to throw some numbers at you, and I want you to think about the units. I'm going to give you the units of the first. So 1, 2, 840, 20. The first two numbers, 1 degree Celsius, it's about 1.3 degrees Celsius, is the global average temperature rise from that pre-industrial level. 2 degrees is the max from the Paris Agreement, which India and US were both part of, right? The next number is 800. The 800 is not 800 degrees Celsius. We're not on Venus. If you are to maintain the 2 degrees temperature rise, we have a budget of 800 billion tons of CO2, the global budget, okay? 800 gig. The next number is 40. That's the rate of emissions of CO2 per year globally. The last number is obvious. We've got 20 years. That's the next 20 years are likely to be the most important 20 years to address this issue. And when I say 1 degree, 2 degrees, of course, it's just a manifestation, representation of the challenge that we are seeing. These are summer temperatures, NASA data. This is data, not projections. And you can see, some summers are hotter, which are red, some summers are cooler, which is, blue. You can see where this distribution is going. And the tail of the distribution, which is the heat waves and the humidity waves, they're reaching places where this is unprecedented. And that tail of the distribution has a more disproportionate effect on human health, on economies, and all that. So this is what's going on. And so we are in this situation. This is pretty scary. So people have realized that we have to do something about it. So now I call this the defining challenge, because this is not just energy. What happens in energy, we'll come to that, affects water. We all know this. What happens in water affects food, biodiversity, ecology, global health, and climate change affects all of them in generally an adverse impact. This is the sustainability challenge. So people have realized this is a problem. And so the global commitments that have been made in Glasgow, right? India's 2070, US is 2050. The United Nations has sustainable development goals. More than 60%, I'm told, is 80% of the Fortune 500 companies have made some kind of climate and sustainability commitments. They're trying to figure out how to get there. The commitment has been made. They're trying to figure out the details. The details have not been worked out, okay? This is like marriage. You make a commitment, then you have to work out some details, right? So that's what's going on. And no one really has a pathway through. You ask any corporation if they say they have a plan, please let me know. So given all of this, but the question is, what do we need to do? This is the macroscopic picture. On the vertical axis is CO2 per year, CO2 emissions per year. On the x-axis is time. And so I call this scale versus speed. And if you look at the red line and the blue line and the yellow line, that's the decarbonization effort that needs to be done. It's in tens of gigatons, 50 gigatons per year. That's not enough. This blue line is the negative emissions. These CO2 molecules have to be there, will remain there in the atmosphere for several hundred years. So the CO2, the waste that the West has produced over the last 100 years or so, most of it came from the Western economies, right? We have to remove our own garbage, to put it bluntly. Otherwise, we'll have problems. So this is the macro picture. But of course, this is not going to happen by extrapolation of the past. So how do we address this? I'm throwing out these gigatons as if these are just numbers. So let me give you another quiz. What is the weight the total weight of all 8 billion human beings on Earth in gigatons. Okay? Remember, tens of gigatons. What is the weight? Half a gigaton. Okay? We're talking about new industries that need to be created. And we are seeing early days of that right now. That's the opportunity. So you have multiple gigaton scale, $1 trillion per year industries that need to innovate. Electricity, heating, transportation, you can go down the line, including information. If you look at the growth of energy use and information, it is pretty, all the chat GPTs that we do, that takes a lot of energy. So they have to transform. This is the largest transition for humanity. 8 billion people going to 10 billion, $100 trillion economy that is based largely on fossil fuel and with emissions that need to transition in the next 40, 50, 60, 70 years. The next 2 decades, the most important ones. And that's the opportunity to seize. So what has happened so far? Energy innovations of scale in the United States. We have been fortunate with natural gas. That has emissions. But also renewables. This is the first time in history, human history, that renewables at this scale, of terawatt-hour scale, is one of the cheapest way to produce electricity. So it's not a surprise that you're seeing all these investments. Last year, $1.8 trillion investment globally in renewables. In oil and gas, $1 trillion. Okay? So you're almost a factor of 2. Batteries, we all know, electric vehicles, and if it comes down to, goes down by a factor of just 20, 30% or more, we can have electric vehicles cheaper than gasoline vehicles. And of course, this has been picked up. And let's not forget energy efficiency light-emitting diodes, which are becoming as cheap as incandescent line. So why would you put in incandescent which is more of a heater with a little light source? But this is not enough. There's a lot more that needs to be done. You need multi-grid scale storage at 1/10 the price of lithium-ion batteries. There's small modular nuclear. We can't ignore nuclear. There's refrigerants. This is the cooling thing that, when refrigerants have a global warming potential of 3,000 times that of today's refrigerants. Energy efficiency in building. Industrial side is one of the most difficult one. Maybe hydrogen, right? There's a lot of interest in hydrogen, steel, cement. And there's a standard question that if you can't decarbonize steel and cement, it's going to be very hard to decarbonize the economy. Because that's the infrastructure that we build. Food, by the way, is 25% of the emissions, food and agriculture. And there needs to be this huge sucking sound of CO2, okay? That has to be put somewhere. In the interest of time, I'm going to go, so at Stanford, we realize this is a defining issue of this century. And academia, with business school, engineering, sciences, law, it's not really geared up to address this challenge. Because this is not just a business or an engineering issue. This is all of the above. So we have business schools, engineering, but we decided to launch this, the first school in 75 years, with a vision to create a future where humanity and nature, those 10 billion people and nature can thrive together. But this cannot be done alone. This has to be done in partnerships. The whole idea is to create knowledge, co-create scalable solution. We, sitting here, do not understand fully the challenges in India. That needs to be co-created and co-developed with partners worldwide. This is about the opportunity of the lifetime. I'm an engineer. Engineers, we generally look at, let's solve the problem. Well, this is the biggest problem we can think of creating knowledge and scalable solutions innovation. I'll give you a few examples. We're sitting in Stanford. This is Fred Terman, was the dean of engineering, who had 2 students, Hewlett and Packard. That led to this growth of Silicon Valley, right? And we are sitting here. This is named after Jensen Huang. That's Y2E2. This is Jerry Yang and Akiko Yamazaki. There's Ram Shriram, Google, and Spilker, which is GPS, right? We are the beneficiaries. It started from here as the beneficiaries of this innovation ecosystem. And in the energy area, we have a center after Tom Steyer and his wife of the sustainable innovation. And that has, over the last decade, we've invested just small amounts, 100K, 50K, $6 million. Follow-on funding, $1.6 billion. Okay, Okay, so this is how you start to launch innovations, because sometimes for large companies it's very difficult to move, but small can do that. This is already there, and we felt this is necessary but not sufficient. We have to think about scale, and we have launched something called the Sustainability Accelerator, which is preparing for scale-up. It's not just startup. It has to be at scale-up. So you have to prepare for the scale-up when you start up from the beginning. And I'm going to harken back to the moon landing from the US perspective now. This goes back to September of 1962, President Kennedy launching the moonshot of we choose to go to the moon in this decade, not because it's easy, but because it's hard. It's an organizing principle to get everyone focused on where you want to go. We are taking that on scale and destination seriously. We have called this accelerator. We have multiple flagships now. The first one is greenhouse gas removal of CO2, gigatons of CO2 per year at less than $100 a ton by 2050. That's quantitative metric. That's where we want to reach. Now the question is, what will scale up? You have to ask the question. And there are many more. Adaptation. This is super important. Adaptation for billions of people against the tsunami of climate change. And protecting land and water, feeding, food security is going to be a huge issue. Right? So we have to work backwards now, just like those NASA people did. Work backwards from the destination, thinking about the scale, and that's what's going on. There's lots of issues. It's not just technology then. It's about finance, about policy, equity, supply chains, education, and at scale, unintended consequences. We are living in the unintended consequences of the 20th century. This at scale will have unintended consequences. We have to think about that. And then you start up to scale up. That's what we're going after. Let me end by, this is our North Star of the school. This is a very different kind of school. It's an all-campus effort. And this is about harnessing all the powers we have. Knowledge, education, talent, innovation, partnership, influence, to really restore it for our kids and grandkids. And in the words of Martin Luther King, who was a big fan of Gandhi, the fierce urgency of now. Of course, he used it for a different reason. And our North Star, real North Star, is a different way of looking at the future. We do not inherit this earth from our ancestors. That's a typical way. We are really borrowing this from our children. So this is all about the future. Thank you very much.